really is, as I mentioned, somebody that has the same molecular formula, but really a different connectivity that occurs. And one really good way, as I sort of demonstrated there at the very end, to sort of figure out whether or not you kind of drew different isomers is to really name things. So naming is really a critical part of organic chemistry. And I sort of outlined some of the steps there at the end. And obviously we're going to go more over it again on Monday, but let's just kind of highlight really those sort of steps for naming. So when we go to name, really alkanes or pretty much any organic compound, as I mentioned, what we're looking for is that longest continuous carbon chain. And it doesn't have to be the straightest chain. It could actually go straight and then go up and over and stuff like that. Again, the only thing that you can't do, as I mentioned, was kind of go one way, back up, back up, and go back. So you kind of have to go in one direction until you kind of hit a dead end. And once you do that, that is going to match one of those first 10 alkane names that we talked about in that table. And that's really going to become kind of the base of your name, is going to be that longest continuous carbon chain. Now, as we saw at the end there, once we sort of get that longest continuous carbon chain, there's going to be some groups that are going to be attached to that. And these are guys that are really not part of the longest continuous carbon chain. They are essentially like our branches that we were talking about, kind of, attached to the main trunk of the tree, right, is all the branches. These guys are attached to that longest continuous carbon chain. Now, most groups that are attached are what are referred to, as I mentioned earlier, as alkyl groups. And alkyl groups, again, are also based off of those first 10 alkanes. The difference is, as we talked about there, is they're missing one hydrogen. And they're missing that one hydrogen to allow it a place to connect to the chain. And again, with that hydrogen still there, if they tried to connect, they would have too many bonds to the carbon. So it's missing those one hydrogen. And that's why we saw like that CH3 group has one carbon. It's based off of methane, but because it's missing that hydrogen, it is known as a methyl group. If we had C2H5, that is two carbons. It's based on ethane. Ethane missing one hydrogen is a ethyl group. If you had C3H7 there, right? 3 carbons normally would have 8 hydrogens. It's missing that one hydrogen, and that's propane, and that becomes a propyl group. So when you look at sort of those groups that are attached on the outside, that are not part of the chain, they will match in most cases one of those first 10 alkanes. The only difference between the 10 alkanes and that group is it will be missing one hydrogen. The purpose of it missing that one hydrogen is it allows it an opportunity to actually connect in without having too many sort of bonds. And basically you continue on in this fashion. If you had a 4-carbon group attached, 4 carbons is based off of butane. If it's missing one hydrogen and it's a group, it would be a butyl group, and so forth. Continue on a pentyl group, a hexyl group, and so forth as you continue through. Now, there's also some other groups that are attached very commonly, as I just mentioned just a second ago, and those are like the halogens, right? And that's like your, fluorine, chlorine, and bromine. So these are kind of named like floral, chloral, and bromol. That is sort of how we name halogens when we have them attached here. So kind of floral, bromol, chloral, iodo for iodine. It becomes something like that. And there's actually some groups that have kind of historical names. And the very common one is, actually, that's not the right way to draw it, is this guy here. where the connection's actually right there in the center. This is also a 3-carbon group. And you might say, well, 3-carbon group is a propyl group. But this is actually what is known as isopropyl. So you may be saying to yourself, what is the difference? So let me kind of explain the difference between those two groups. And the difference really is in where the attachment occurs to the chain. If you take what is sometimes referred to as just a normal propyl group, that is basically, I'll just draw it out like this. Looks something like this. Where the attachment would occur here at this carbon right here. Now, what is that carbon, right? So you might be wondering, what is this sort of carbon compared to our isopropyl group? Is there really a difference between, those different carbons? And again, if we draw out this carbon, the attachment is actually happening right there. It is happening in the center. So you might be wondering, like, is there a difference between sort of those carbons? And there actually is a difference. We can actually classify these carbons at what is known as a primary carbon, a secondary carbon, and a tertiary carbon. So how can you determine, what type of carbon you're dealing with? Well, what you want to do is actually, the simplest way to do it is, circle the carbon you're looking at. And basically a primary carbon, it's attached to one other carbon directly. So this carbon is directly attached to one other carbon. Hence, primary means one, and this would be a primary carbon. A secondary carbon is a carbon group that, as you might imagine, is attached to 2 carbons. 1 carbon. Tertiary is attached to 3 carbons. So let's take a look at this carbon. Directly attached to that carbon is one other carbon here and one other carbon here. That is 2 carbons attached to it, which means that this is a secondary carbon. So the propyl group, or sometimes referred to as the normal propyl group, attaches at the primary carbon, either at the left-hand side, right-hand side, doesn't really matter, but it attaches there to the primary carbon. This attachment to the chain happening at the secondary carbon is what makes this group different and known as an isopropyl group because of that. This carbon right here would be if we look at this carbon, it's attached to 1 and 2 other carbons. That also is our secondary carbon. This carbon at the end is attached to only 1 carbon. That's a primary carbon. This guy over here would be a primary carbon, and this guy over here would be a primary carbon. So sometimes, depending on how that group's attached to what carbon it's attached to, or attaches sort of to the chain, as to where we get some of these names. And that's why sometimes people might even call this propyl, but most people call it isopropyl. It's a historical sort of name, and it's a very common group. Question on sort of those names, or primary, secondary, or tertiary. If you're interested in what a tertiary carbon might look like, if you had something like this, do something like that. If we look at this carbon right here, it is directly attached to 1 carbon, 2 carbons, and 3 carbons. And that would be a tertiary carbon in that case right there. Now, sometimes people might go like, this guy is this guy a primary, secondary, tertiary? This guy would be a primary carbon. So sometimes people, because it's drawn in condensed formula, again, miss the idea that it's actually attached to this carbon, right? So that would be a primary in that case. Question on that. Okay, so now that we kind of understand sort of the groups that are happening, these are the main steps. We want the longest carbon chain. I recommend putting a box around it. You might want to even circle all the groups that are not part of the chain. And once we do that, we want to identify the groups. And then the important part is to number the chain. And you saw me do it a couple of times there. Number the longest carbon chain. And the purpose of that is you basically have 2 ways of numbering, like left to right, basically, or you can number kind of right to left in most cases. And what determines which way you should number that chain is you want to give the groups the smallest number. And it is as simple as if you're comparing one way or the other, and it's like a 2 versus a 3, 2 is smaller, and that would be the way you would want to go. Once you got the longest continuous chain, once you've identified what all your groups are, you want to number it in the way that gives those groups the smallest number, and then you want to put it all together. And the way that we put it together is a couple of things. When we go from a number to a letter, we use a dash between it. When we have 2 numbers that come back to back, like that very last part, we use a comma between the 2 numbers. And the naming is all about telling people exactly where you can find everybody. Any questions on that there? All right, so now that we kind of got the order here, let's actually look at one here together and kind of dissect how we should go about doing this. So let's say we have this guy right here. Okay, so this is our guy. I want you to take a second and first try to figure out the longest carbon chain. So take a minute or so here and find the longest carbon chain. Try all of your options. Remember, the only rule is you can't go back. So you got to start in one direction and hit a dead end wall, sort of. Find that longest continuous carbon chain. Always makes sense just to go just straight across. Yeah, so might as well very badly highlight the thing straight across. There we go. And if we count it 1, 2, 3, 4, 5, 6. So basically 6 straight across. Now, there's other options, and you do want to check kind of your other options as well. So if we kind of start at the left and decide, let's go upwards, if you will. Let's go this way and then head up, right? That is 1, 2, 3, 4, 5. That is less, so that's not going to work so well for us. So that's not good. Let's go straight across and then up at the second option there, kind of straight across and then head our way up here. That's going to be 1, 2, 3, 4, 5, 6. So that is 6 as well, going in that direction. So far 6 is looking like a winner here. We actually got a couple other ways. You can go 1, 2, 3, 4, 5, 6 upward. Also gives us 6. You could also, if you wanted to, go 1, 2, 3, 4, 5, and 6. Also 6. So 6 does look like the winner. There's a variety of ways we could get to 6. You could choose any way you want. They all should probably end up at the same answer. regardless of which way you choose. I kind of recommend going with the straight approach. So I'm going to go with just straight across here. This is going to be 6, which again is the longest. This again is going to be my main part of my name. 6 carbons in organic chemistry, all single bonded, means that the base of my name is hexane. Any questions on that there? Now that I've identified the main part of the chain, there are some things there that are basically groups attached, right? And we want to identify these groups. So if we look at this group, we have a 1 carbon group. 1 carbon group means it's based off of methane. And because it's an alkyl group, this now becomes a methyl group, YL. Any questions on that? We also have over here.
Yeah, I'm sorry, Professor. Why is it a methyl group again?
So it's a methyl group because it's not part of the main chain, which is in green. It's a group that's attached, and the only way for that guy to attach to the main chain is it has to actually have 1 less hydrogen than methane, because methane is CH4. This is CH3, and it has that 1 less hydrogen because that's where it's able to attach to the main chain. Because if it still had the 4 hydrogens, it would have too many bonds. So that's how we could recognize that it actually is a group, other than the fact that it's actually not part of the longest continuous carbon chain. That sort of automatically makes it a group. But that basically tells you it's a group because it's really not part of the chain. It has 1 carbon. So because we know it's a group, it will be based off of methane, and it also will have 1 less hydrogen than methane because it needs that place to attach.
Got it. Thank you.
You're welcome. Other questions? Now we want to look at this thing the same way. We see it's not part of the main chain over here, so we know it's a group. It has 2 carbons. So 2 carbons on those first 10 is ethane. Because it's a group, this will now be a ethyl group. Question on that one there. So now we have a methyl group. We have an ethyl group. We pretty much need to give the location where we can find those groups on the chain. And this is where the numbering part comes into play. We can number the main part of the chain, which is in green, left to right, which means this is carbon 1, this is carbon 2, this is carbon 3, that's carbon 4, that's carbon 5, and that's carbon 6. We could also number that main chain going the other way. This would be carbon 1, this would be carbon 2, this would be carbon 3, this would be carbon 4, this would be carbon 5, and that would be carbon 6. So you may ask yourself, which way should I choose? Well, we actually have 2 different groups here. And when we put the groups in our name, we want to do it in alphabetical order, which means we want to number whichever way, in this case, kind of gives our groups the smaller numbers, but we do want to put them in alphabetical order. So let's see if there is sort of a difference. First off, going in the red direction, at carbon number 2, there would be a group. So at carbon number 2, there would be a methyl group going in the red direction. At carbon number 4, there would be an ethyl group. Now, where are those groups if we go in the blue direction? In the blue direction, we have at carbon number 3, a ethyl group. At carbon number 5, we have a methyl group. So these are our 2 options here. We have basically, in terms of our numbers, 2 and 4 versus 3 and 5. Now, which one is the smaller number? It is the 2, and it very much is as simple as 2 is smaller than 3. So because 2 is smaller than 3, this would be the way we would want to number the chain in the red direction here. Question on that? Okay. Because we're going to number in that direction, that means, again, at carbon number 2, we're telling people, if you go to carbon number 2, you will find a methyl group sitting there. If you go to carbon number 4, you will find an ethyl group sitting there. Now that we have all of our parts to our name here, we basically are going to put it together in alphabetical order for our groups, regardless of the prefix. There are no prefixes here. So alphabetical order is E before M. Now you may be saying to yourself, but wait, the E has a bigger number than the M. Doesn't matter. It's alphabetical first, regardless of number. So now that we established that these are the numbers, we would call this 4-ethyl. 4 is a number separated by a letter with a dash. We are now going to go 4-ethyl dash 2-methyl. Again, letter number separated by a dash, hexane. So this would be 4-ethyl. It looks like a Z, but it's actually a badly written 2-methyl hexane in that case. Question on that name there. And really, naming in organic chemistry is really just all about telling people exactly where you can basically find everything located. So to recap, we want to go longest continuous carbon chain. That will give us the base of our name. We then want to figure out what all the groups are, and we want to find the numbering that gives those groups the smallest numbering, and then we want to put everybody together in alphabetical order. Any questions on that one there? So why don't you try maybe, let's go with, why don't you try one here? Flip the page, get a fresh page. Let's go with, CH3. We'll go CH2, CH2. Let's go C. Let's go C. Let's go CH2, CH3. Let's attach some things here. Let's go with a CH3 there. We'll do an H up there. Let's do a CH2, CH3. We'll do an H there. And let's do a CH3 and an H. All right, give it a go, see what you come up with here. Again, a lot of stuff going on this guy. Do it in the order, find the longest continuous carbon chain. Once you do, put a box around it, whatever you want to do, highlight it, then find all the different groups attached. And then you want to, again, figure out which way you should number this to give you the smallest number, and then put the groups together in alphabetical order first. So take a couple minutes and then we'll talk about it. The goal is, again, you want to kind of try to find that longest continuous carbon chain. Trust me when I tell you, it never hurts just to run straight across and see what you got going on there, especially in this thing. We got a pretty long one. That, I believe, is 1, 2, 3, 4, 5, 6, 7, 8. That's probably going to be the winner, I think. But if we go 1, 2, and up is 3, that's not going to work. 1, 2, 3, 4, 5, and then up, 6 and 7, that's still less. We could go, I suppose, 1, 2, 3, 4, 5, 6, and 7. That's short. We could go 1, 2, 3, 4, 5, 6, 7. We could go 1, 2, 3, 4, 5, 6, 7, and 8. So our other option is kind of starting at the right-hand side and then hanging an upward direction at the end there. So it looks like 8 is the longest. And if you have the option, probably again, the straightest part of that is probably a good move. 8 carbons in a row is going to be octane as the base of our name. We now want to kind of look and see what we got going on in terms of groups. Well, we got a 1 carbon group there. We got a 1 carbon group there. And we got a 2 carbon group there. Again, these are groups that are not part of the main chain, so we know they're groups. They will be named just like our first 10, but with the YL at the end. So that is going to be a methyl group there. That is going to be a methyl group there. And this 2 carbon group here is going to be based off of ethane, and that would be an ethyl group. Any questions on those identifications? All right, so we have 2 methyl groups in the same compound. So as we talked about earlier, when you have 2 or more groups, 2 is di. So we've got like a dimethyl happening. Again, because there's 2 methyl groups, doesn't have to be on the same carbon, but in the same compound. And we also have an ethyl group. That then brings us to our numbering. So we want to number this. Basically, we have 2 options. We're going to go left to right. That's going to be carbon 1. That will be carbon 2. That would be carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, and carbon 8. Going in the blue direction, we have groups at carbon 2. We have a group at carbon 5, and we have a group at carbon 6. If we numbered right to left, we have this is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, carbon 5, carbon 6, carbon 7, carbon 8. Going in the green direction, we have a group at carbon number 3, carbon number 4, and carbon number 7. So when choosing here, it's always the smallest, which means this side would not be good. We actually want a number in the blue direction. Any questions on that? Just get rid of some of these numbers here. Clear it out a little bit. Okay. So now that we've established that we're numbering in the blue direction, we basically are pretty much done. We know that we have a methyl group at carbon number 2. It's also at carbon number 6. So that's 2,6 dimethyl in terms of our naming. We have a ethyl group at carbon number 5. That's a 5-ethyl. What is left but alphabetical order here? Can't be that easy. And you're right, it's organic chemistry, so they got some weird rules. It is alphabetical order without the prefix, which means we're comparing M to E. And alphabetically speaking, E is before M. So that's one of those weird IUPAC rules. If you have to use a prefix and it's not a recognized prefix, like a historical name, you actually don't use it for alphabetical purposes. So we would actually start in this case with 5-ethyl. Again, E before M, dash 2,6, because we have to give the location of each of those methyl groups. Dimethyl, because there are 2 methyl groups in the entire compound. And lastly, we tack on octane. Any questions on where any of those sort of numbers or parts came from? It again is all about really telling the person that's looking at it where you can find everything. It's all just about location, 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 basically. Again, we see the couple of things we talked about. Between a number and a letter, a dash. Between 2 numbers, a comma. Any questions on sort of naming from a formula? If you did halfway good on this one, you should be in pretty good shape. There's a lot going on in this guy. But again, you just want to kind of take it in order. Any questions on sort of the naming part here? So we're getting to the end. So I just want to do one more thing with you, which is going from the actual name to the formula, which is also a very important thing to know how to do. And we'll talk about obviously on Monday as well. But let me just do a couple examples of that. It's actually, in my opinion, the easier thing of the two is actually when they give you the name and you have to write the formula. So let's say we had 2,3-dimethyl butane, and we wanted to, write the structure for it there, or draw the condensed formula for it, and so forth. Let's also say we had something like, something kind of weird, like, let's say we had 5-ethyl, 3-methyl, let's go with octane, right? So you may be looking at these and go, whoa, this is probably going to be kind of hard to do. So let's say we want to write the condensed structure for each of these. Whenever you're given a name, it's always important to actually work yourself backwards. So what do I mean by that? Well, if I dissect this name, I start on the back, and we know that the back part of the name is basically how many carbons there are. So butane tells me I should lay up like 4 carbons. Again, I'm just going to kind of do the just carbon skeletal structure. I'm doing a lot of spacing there. I'm not sure why. But we got 4 carbons in a row. That pretty much takes care of the butane part. Dimethyl, methyl is a CH3 group. Di means, as we just saw, there's not one of them in that compound, but there is 2 of them in that compound, right? Where are they located? Well, one is located at carbon number 2. The other is located at carbon number 3. Which one is carbon number 2 here? Which one is carbon number 3? The good news is, since you are drawing it, you can do whichever way you want. I'm going to call this carbon 1, which means this is going to be carbon 2. That would be carbon 3, and that would be carbon 4. You could start here as carbon 1 and go to the left. Now, because I did that, I would go to carbon number 2 and draw my methyl group. That takes care of that guy. I would then go to carbon number 3 and draw my methyl group. That takes care of that guy and that. So what is left? My picture looks a little sad, right? What did we talk about in terms of what is pretty much everything else at this point? Everything else at this point is hydrogens. How many hydrogens do I need? It's what we talked about earlier. This guy has 1 line coming in, which means in order to get him to 4, you need 3. Am I really spaced out lines for some reason here? This guy here has 3 lines coming in, which means he needs 1 hydrogen. This carbon has 1 line, 2 lines, and 3 lines coming in, which means he needs 1 hydrogen. This guy at the end has 1 line coming in, which means he needs 3 hydrogens. You probably wouldn't draw it that spaced out, but that is the way that you want to approach when you're given the name to draw the structure. It is actually the easiest of the two because it kind of tells you what to draw. Question on that there. All right, so if you'd like, take a moment here and give this a go and see what you come up with. Again, start backwards, do just the carbons, find your carbons and add your groups, and then add your hydrogens. So take a moment and then we'll see what you come up with. Okay, since we're a little bit over here, let's talk about it. So again, always work backwards when you're given the name. So we would start here at octane. Octane means 8. So the first thing you just want to do is just basically lay up 8 carbons. Definitely should have picked something with less carbon. So let's see, that is 1, 2, 3, 4, 5, 6, 7, and 8. Whew. All right, that takes care of that part. What's left are the groups. So we have a methyl group, which again is a CH3 group. That is at carbon number 3. That's basically what this means. We also have an ethyl group. So ethyl is based off of ethane, which means it's a 2 carbon group. and that's at carbon number 5. Again, if you want, you could write the ethyl group like that. Sometimes people will do C2H5, same thing, however you want to do it. This would be more the condensed way of doing it, obviously, down here. So just because, as we talked about before, because you're drawing, you can number these carbons left to right, or you could go right to left. Again, I'm going to call this carbon number 1, and I'm going to head in the right direction. That means when I go from carbon 1 to carbon 2 to carbon 3, that is where my methyl group should end up. So I'll add my methyl group. That takes care of that. Obviously, this is carbon number 3 where I put my methyl group. Next to it would be carbon number 4, and next to that would be carbon number 5 where I would put my ethyl group. That takes care of that. At this point, everybody else is hydrogens. Again, the goal here is to get carbon the 4. So you can basically count the lines coming into the carbon. So coming into the guy at the end is only 1 line, which means he needs 3 hydrogens. The guy next to him has 2 lines, which means he needs 2 hydrogens coming in. The guy next to him actually has 3 lines coming in. So to get him to 4, he only needs 1 hydrogen. The guy next to that has 2 lines coming in, which means to get him to 4, he needs 2. The guy next to him has 3 lines coming in, which means he also only needs 1. Guy next to him has 2 lines coming in, gives him 2 hydrogens. Guy next to him has 2 lines coming in, gives him 2 hydrogens. Guy at the end has only 1 line coming in, which means he needs 3 hydrogens. And that crazy name gives you a big old structure, but it is, in my opinion, the easier of the two because it actually tells you what to draw. The key here is just to work your way backwards with the name. Question on how to go from name to formula. Okay, so we're a little bit over, so thank you for hanging out. I hope this helps. We obviously will do some more examples on Monday during lecture and all that good stuff. So have a nice weekend.